All right, welcome everybody. This is Quick Wins, Performance Tuning, MySQL, and third-party patches, specifically about InnoDB and ExtraDB, and we have our world-renowned speaker from Percona, Morgan Tucker.
Hello? Does this work?
No.
No, I don't think so. Hello? Awesome. Hello? No, I don't think... I can speak with that one. It's fine.
Can everybody in the back hear?
I'll try and raise my voice. Light just went on. That it? No. All right, it was actually working before, but now it's not. So, how you doing? So, my name's Morgan. I work for a company called Percona. You probably know Percona best for this. We run a blog. It's called MySQL Performance Blog. This isn't really our business. We're a consulting company. This is our marketing, and this is our gift back to the community. So, I'm going to be talking today about performance, but the talk comes in two parts. So the first part is I'm going to look at performance tuning a MySQL installation. The second part is I'm going to look at some cool stuff that's happening in the MySQL world. So, any questions? Yes?
Are these notes can be posted somewhere?
I'm going to hand them over to Eric, and then hopefully he'll post them. I have a lot of notes at the bottom of my slides with links and things like that, so certainly it'll be helpful to get them after.
I'm going to pass around the link to everybody through Meetup with the video, and I'll make sure to put the notes on as well.
And I'm posting it to Tech Presentations for sure. So.
Okay, perfect.
TechPresentations.org.
I want to say one other thing, and that's if you've got any questions, interrupt me. I love it if you ask questions. And if it's a long question, then I'll take it offline, and I'm comfortable to tell you that as well. Interaction is fun. So let's start with part one. So you've written an application, you've inherited an application, usage is going crazy. You've diagnosed the database is the problem. Where do you go next? So that's sort of what this talk is about. It's a system that hasn't been shown any love. We know database is the problem. Where do we go from there? There's three ways that people go about this generally. And I want to show you all three and compare and contrast them. And sort of my mind as a consultant, that I've inherited this system, and what do I think? So the three options that people take are, option one, they just upgrade the hardware. Option two is they just try and change configuration in MySQL. And option three is they look at indexing, and they tune queries. So first with option one, I say this kind of works, but for how long does it work, right? We have this finite size of a machine that we can purchase. And there's this price point where the big machines get expensive. The thing that I notice a lot of people do wrong with this is that they buy the big machines, but they don't really diagnose what their bottleneck is. And so if you buy big, fast CPUs, and you're not CPU bound, this does nothing. So big machines have the same speed drives, check what your bottleneck is. And so if you don't know how to do that, here are sort of the four potential bottlenecks, and my thoughts on each one of them. Disk is a big bottleneck for a lot of people. So if you're looking at machines, generally it's different. So don't let me speak generically to you. It can really lead you down the wrong path. Disks are so much a problem that we sort of try and cheat, and we use RAM to be able to relieve that, so that our reads can come from memory. It's only our writes that have to persist down to disk now. CPUs aren't necessarily a problem themselves. So much so, and my apologies that it's a little bit low, so much so a CPU is not the problem that we can now do things like compression in memory so fast to be able to reduce our I/O. And this is just like a shift in bottlenecks. With MySQL, sometimes we have a little bit of a problem where we can't take advantage of too many CPUs. But if we have fast CPUs, sometimes that's a little bit better of a strategy. This gets better. It's better in MySQL 5.4, hopefully to be released at some stage, and it's better in things like ExtraDB. And network, I wouldn't say that network is too much of a bottleneck for databases. I'd say that I'm not going to be silly with round trips by just requesting items one after the other from the database. I'd try and sort of group statements together if I can. But other than that, networks, it's not a bottleneck. Questions?
Yeah, just a quick one about the disk. You mentioned
Sure.
RAID 10. What about SSDs?
Yeah, SSDs are they're cheaper on an IOPS basis, which is a little bit of the currency that we're working with, but they're still a lot more expensive on a storage basis. I think that if you look at some of the SSD options available, which is still kind of expensive, and if you compare it to something like a nice RAID 10 system with a fairly well-priced RAID controller, for most people the economics is still on the RAID 10 controller with the disks. It might be interesting if vendors like Sun could make things a little bit easier so that we could mix and match. Like, the traffic on indexes is a lot more random, so it'd be really interesting if we could separate our InnoDB data files so we had an index table space. We could put that on SSD. We could have our other stuff just storing on our RAID 10 volumes. But at the moment, nothing like that exists.
I have something to add to that,
Okay.
actually, because I just had an experience with a solid-state drive failing, and when they fail, there's no way to recover, whereas a hard drive disk, it's a physical thing, and there's recovery software, so you lose whatever was corrupted, but you can still recover from it. If a solid-state drive fails, you're pretty much out of data what's on there, so that's probably a factor most significant to storing data.
If you're going to look at this stuff, look at ZFS. There's some really nifty toys in there with exactly this, which combine the advantage of SSD with the advantage of physical and all the middle ground and everything else.
Yeah,
So,
I have a couple points to add. Yeah, ZFS is nice because you can, with like Sun's open storage solutions,
Which got one in the house today.
you can use something like SSD as like a cache, and it can understand that. I agree with Eric's point. With hard drives, we know how they fail. We can mimic the way that they fail by putting them in a warm room and maybe putting them on racks and vibrating it. And then we know, I think that's the way that they test them. And so we can predict what the like MTBF is of a disk. With SSDs, the technology is still fairly new. And it just doesn't have we don't understand the characteristics of them and how they fail and when they fail. And so maybe they're just in experimental, and if we're a little bit more enterprise focused, we might not quite jump there. But that wasn't my point to start with. My point was that the economics of them aren't quite there yet.
That was the point.
Yeah.
With ZFS and its caching and ZIL and the L2R, you gain benefits from both sides. There's a small amount of SSD space. You gain a lot of benefits while still keeping the economics of the mass storage on the drive. So
Yeah.
you can do weird things. And
The only dilemma with that is that you have to use Solaris, or you have to use FreeBSD, which,
it's a problem.
for my case, it limits a lot of our customers which use Linux.
Right.
They can use the open storage devices that are network attached. That might be one way. We have some people doing that.
It doesn't give you the same
Depends.
benefits quite the same
Yeah.
way. But yeah.
Sun's unified storage, it uses CFS, and you get the box ready to use, and like it supports all the protocols that you want. It supports NFS, it supports Sun, it supports CIFS, and you can mix and match SSDs and hard drives.
In my work, I actually prefer my storage locally attached. I've had some problems with NFS, even with NFS 4.
It can do iSCSing.
I haven't had the pleasure to play with the devices, so I can't comment specifically. But I know people are doing that.
Would you recommend RAID 5 for a read-bound databases?
Yes, sure. Sure, I said RAID 10 a little bit too generically, but it's generally RAID 5 or RAID 10. With my assumption that you're very write-based, then it's generally RAID 10. But if you're read-based, then maybe that might flip and it might be RAID 5. But it's the choice of those two.
Have you guys ever had any experience using the Lustre distributed file system?
I have not. I can't speak for my whole team, but I have not.
I'm just going to add something here. We have tens of thousands of MySQL reads a second, and we replaced a large cluster of database slave database servers, which were using SCSI or SAS drives with Fusion IO cards in our HP Blade servers, and we reduced the number of servers by to 20% of the original number, and we could have gone lower. So SSD, certainly something like Fusion IO, which isn't limited to the drive format, can offer you an order of magnitude of performance. Our MySQL servers are now doing several thousand queries per second, and they're not even working hard. I can push them to 10,000 without being too worried. So if you're scaling on a very large level, then SSDs can just pitch you so far up that it's a whole different ballgame. We do not use them on the masters though. Masters we use RAID 10, the fastest hard drives that we can find, because I don't trust SSDs on my master yet.
It might be a question of data set. I mean, the economics aren't there for everyone yet on SSDs, except for on IOPS bases, they're cheaper. IOPS is I/O operations per second. But in terms of storage, they're a lot more expensive.
The point that I was going to make there was, especially something like Fusion I/O, where you have an entire subsystem designed to work together. Certainly with SSDs at the moment, given that it's kind of a moving target, you definitely have to be very careful about making sure that whatever RAID card you're using works with whatever SSDs you're using. And you can actually end up in a situation where you're getting worse performance than you would otherwise if they're not paired together properly. And I know that probably less of an issue right now with the Intel than with some of the off-brand SSDs. And if you're looking with a vendor like Sun or a Fusion, you know everything's going to work together out of the box. If you're someone who likes to put together their own systems, be careful because some of the RAID cards don't play so nicely with SSDs these days.
Yeah, and some of them don't give that good performance generically. Like, they fabricate their benchmarks by doing really things that don't replicate reality at all. So I certainly agree with that the market hasn't settled for that yet at all. So, great. Thank you for the input. So allow me to proceed. The next point, so that memory problem, how I said we threw memory at our systems to be able to alleviate that disk problem. And I think of this as like a game of Pong. So our memory sits sort of in front of our disks, and we hope that we can sort of hit that memory as like a cache hit, and we don't have to go to disk. And how big does that bar have to be that sits in front of the disk? That's actually a pretty hard question to answer. For some people, it might be 1% of their total data set. For other people, it might be closer to 100%. And we call this the working set in database land. So, so when does this technique of adding hardware solve things? I think it works pretty well if you're just adding memory sometimes. If this describes you, you had really good performance because your working set seemed to fit in main memory. And then performance tanked because your working set couldn't fit in main memory. And so then I have a couple of footnotes here to explain this. That I'll try and explain it quickly. Yeah, it can be between 1 and 100% of the database size. If you don't have indexing done very effectively in your database, it tends to be closer to 100%. And the second point is this idea of just adding hardware. The economic size that you can just add hardware for main memory is 128 gigabytes. It's very cheap to buy a server with 128 gigabytes of memory. Once you go past that point, it's just ridiculously expensive. But until that point, there's a certain range of problems that can be very easily solved by adding this hardware. Make sense? Okay. So let's summarize on this. And what are my thoughts on adding hardware? It can solve the excess money problem very well. It's actually pretty hard, minus that example that I gave with working set, to get multiples better performance by doing this. And it can get expensive once you get past a certain point. So I like this approach, but once I contrast it with my other ones I'm going to show you, it's not my favorite approach. What warning would I give you? I wouldn't use this as my first step. I like my other two that I showed. Tweak buffers and caches, and start working on indexes. So let's go to technique number 2, option 2. This one I like to call the -- run faster option. Because everyone wants these silver bullets. They like searching in Google, how do I make MySQL faster? And they think that this is just some setting that can turn stuff on. I have to tell you that this is not true. Any of these changes that you make, they assume misconfiguration to start with. If you had MySQL misconfigured to start with, you can get better performance. A little bit of a tip on this is that MySQL is pretty badly configured to start with, so it actually works pretty easily.
I should just add that, you're talking about MySQL, but don't discount first looking at an order of the hardware. because I see lots of people who actually misconfigure their hardware.
Absolutely.
You know,
Yeah.
like not booting an SMP kernel on a system for 200 days, or having you know, routers that are cutting down the network bandwidth. So don't discount.
Or
that
or
as well.
very small stripe sizes on their disks, or
Yep.
extension 3 when they've got multiple disks.
Or
and
they're
they've got
running their
serialization.
integrated RAID and didn't even know.
Yeah.
So don't discount that first as well.
Yeah. Thank you. Thank you. So system diagnostics are important, and I'm not doing any of that tonight. I'm sorry.
But you can get, I mean, because things out of the box are not necessarily properly configured, it seems like you should at least look at this configuration settings, don't you think?
Yeah, I do, but I don't think you can get the same multiples. And I'm just trying to relay the information that I think that the benefits are overpromised. And so I don't want you to Google WikiHow or something or other and turn on some setting, which in some settings you get better performance, like delayed key writes, but they have negative consequences. And you just have to understand that this is a reactive process where you look at a command like show global status first, and then you make the changes. You don't just make random changes. And I'll get to that in this chapter.
Yeah, actually, what I was going to say there was quite often these kinds of changes are dictated by the workload, and usually the requirement to make these changes can be caused by a problem in area 3, where if you fix that, then some of these changes, which would have helped you had you continued having a bad workload, actually end up working against you. Would that be a fair?
Absolutely, absolutely. And I'll get to that. I've got a good example at the end of my slides where I say, this is how you do the approach, and beware, because you can overtune. It's certainly true. So, how does this work? Changing configuration. It's a reactive process. We look at this command, show global status first, or there's some other ones like show NODB status, and then we start changing stuff. My first warning with this command is that it will show you all the data from when your server started, pretty much. Let's do something like a flush status. So this information is better trended, and a very simple tool to be able to trend it is this one called Mext. So I look at like 10-second averages over a peak time, or 100-second averages, and then I start trying to get information. So I'm going to show you a few examples of how this works. And only a few, because I don't want to oversell it. You wanted that URL?
Yes.
Okay. All right, perfect. So a few quick examples. All right, temporary tables on disk. So we might look at show global status, and I'm just highlighting the 3 here, and I'm using Mext to make it easier. And here I can see that I created 0 temporary tables on disk, and I created, I think this is 10-second averages from my example here, 421 temporary tables here, 417 in that 10-second average. And here I'm doing pretty good, because I'm not creating any on disk. But if I had some created on disk, then I might want to increase these 2. What's the warning here? The warning is that, and I've got it on my next slide, if we have text or blob columns, these temporary tables get created on disk anyway. So I might have this dilemma where I overtune. I try and increase the size of that temp table size, max heap table size, and it was just useless. So temporary tables, if you're curious, they're created by order by and group by statements in a lot of cases. Sometimes we can actually add an index to avoid that, but I'll get into indexing in my last section. Questions on that? This is to serve as an example. I also have an example to show you that there's a tool that can trend this.
So typically when you increase all these settings, right, that just makes the server use more memory for all these kinds of things. How would one estimate, the memory requirements and all this stuff?
We draw a number out of a hat, and then we times it by 2,
Okay.
and then add 5. No, I mean, MySQL estimating memory usage is really hard.
So
Right.
So what do you do?
You try and put yourself in a situation where you'll never go over what you seem to be using. Because you might try, and there are some formulas that are out there where it says memory usage equals buffer pool plus key buffer size times max connections. It's completely true.
So I'll ask you this.
Okay.
So there's this InnoDB buffer, right, which is the metric thing.
All right.
So how much of that goes into the pre-allocated InnoDB buffer? How much goes on top of the InnoDB buffer?
Okay. So that's a hard one to answer as well. I'm going to try and give you a bad answer to be a little bit easier. So I think part of the reason everybody would love if you had 64 gigabytes in your server and you said, MySQL, here's 60 gigabytes, knock yourself out. It can't work that way, and I don't think it will ever work that way, because MySQL is like a combination of all these different systems, where it's MySQL globally, and then it has these storage engines and things like that. So if you're using, say, both MyISAM and InnoDB, how would it work out when InnoDB starts stealing memory from MyISAM and stuff like that? So each of these things are kind of configured individually, and it's wild, wild west. They just keep allocating memory while they can, until you start swapping or whatever. So it's your job just to make sure that you don't over-allocate. The next thing is, there's a lot of things in MySQL that are completely unbound in terms of memory usage. InnoDB Data Dictionary is a big offender. It can use a lot of memory, and there's no way to set a limit on it. Another one is that InnoDB buffer pool size, even though you say that it's only going to be 20 gigabytes, it takes between, say, 5 and 10% extra overhead for metadata. So just by looking at the raw numbers that you're allocating, you never completely know. The way that you look at it is that you set your server to something, you run it in production, you look at free, you look at top, and you see what the difference is of how much you've got free, and then you tweak for subtract or add.
As far as that thing you said with the metadata and data dictionary, isn't that what the additional buffer pool is for? Because most people never remember to set it. Okay. That's what holds it.
So what the additional, it's called additional mempool size, that's the one you're talking about. So generally people allocate that to 20 megabytes or something like that. That is the starting point. It grows past that to any value. So up until that size, it uses InnoDB's internal memory allocator function to be able to allocate that, and it can just go straight past that. So you could set that to 5 meg, 10 meg, 20 meg, doesn't change anything. It'll just keep going.
So would it be better just to set it to, like, say, a gig?
No, probably not. I'd set it to like 10 or 20 meg. It actually turns out that it's not scalable under multi-CPUs in InnoDB's memory allocator. So I would prefer to use the operating system memory allocator. So set it to 10 and 20. That's cool. But yeah, it's unbound. There's a lot of things in InnoDB and MySQL that are unbound.
If I remember correctly, there used to be some blog entry on MySQL performance blog about having the inno buffer so high so that if you're doing InnoDB recovery, there's some problems and stuff.
Yeah, that's very specific. So the algorithm that it uses to do crash recovery, it actually works out faster if you disable direct I/O and you set a smaller buffer pool. And then you let it crash recover. And then once it's crash recovered, you shut it down nicely and you increase your buffer pool back up to what it was and you turn autodirect back on. But that's true. We have a patch in ExtraDB to make crash recovery in InnoDB faster. As far as I know, with that patch, you don't need to do that workaround anymore. Questions? No. All right. Next one. And these are random. I'm just picking some things to show you how this approach works. Binary log cache. So while we're spooling changes in a transaction, and we're going to write them to our binary log, which is what we use for replication point-in-time recovery, we try and do that in memory. Binary log cache use. If it ends up too big, what we're doing, we spill it out to disk. So this is like a cache hit, and this is a cache miss. If we wanted to, maybe we could increase the size of this if we see some cache misses. I don't see this a problem too much. I see this a problem when people use row-based replication because the binary log events tend to be bigger. But this is the example of how this approach works. Next one, table cache. So MySQL requires a copy of each table open per connection while it's working on that table. The default table cache is lower than the default max connections. I find that silly. So here we have our table cache most likely set to 64, because when we do show global status like open tables, we can see that it's at 64. Because we keep getting cache misses, open tables just keeps on incrementing. So if we see this the same value as this, we may want to increase our table cache. Healthy for most operating systems. Windows, it's not. MySQL cannot keep a lot of file descriptors open on Windows. I've seen systems that set this well into the thousands and they don't have too much problems. Okay, next one, thread cache. Each connection in MySQL is a thread. You can reduce some operating system thread creation and destruction overhead by setting a small thread cache. Here's our threads cached. Each time we have a thread created, we have a cache miss, and we can tweak this if we wanted to. You'll get my slides to see these ones afterwards. Last one, show global status. We see select full join anything more than 0, and we know that we have a query that's joining on 2 tables and it's not using an index on either. Generally, this is a mistake. It might mean that we're either not indexed or we're doing a join without a join condition. And that's really the end of my example of how this works. I could show more, but I don't want to.
Can I ask a question?
Sure.
InnoDB thread concurrence variable.
Okay.
What about what how can we comment on that?
Generally, we set it to 0. Okay, I'll try and answer that. So, InnoDB internally, it's got some flack over the years for being very bad at CPU scalability. And so what we could do is we could reduce the amount of things that InnoDB was doing at once. It's a bit of an ugly workaround by setting a setting called InnoDB thread concurrency. For most cases, some of the internal algorithms have improved a little bit, in which case we don't have to set a limit and we set InnoDB thread concurrency equals 0. Particularly prior to MySQL 5.4, if you weren't one of those workloads that had problems with the CPU scalability, setting a thread cache of anything was actually a bad idea because it had additional locking to be able to guarantee that there was only that many items being worked on at once. So my default policy is to have an InnoDB thread concurrency of 0. And if I know that I'm hitting the problems, which is probably a discussion a little bit too technical to say easily, then I might set something to like 16 or whatever and experiment. It's very specific, that one, and you often have to experiment. My 90% case would be it's a 0.
Are you talking thread concurrency for
InnoDB?
But is extra DB automatically out of it?
So XtraDB is pretty much InnoDB, and in the case of XtraDB, the default is 0. Sir, unless you said it, I think in the 5.0 releases it had different defaults as it was maturing, which is a little bit of an interesting story in itself. But from 5.1, I think for everything the default is 0, unless you tweak it otherwise. And that seems to be the conventional wisdom, that 0 should be the better default, unless you run into a situation. I'm going to invite Ronald if he has anything to add to that. He sees a lot of systems.
No, I think you're right about that. Particularly if you read the history about the variable in 5, it actually went up and down several times.
It was madness.
It was crazy.
It was like a roller coaster.
Yeah. Unpredictable roller coaster. But yeah, normally it's only when you get into high workload that you actually find a thread-related issue. And so you can actually see that within InnoDB status as well. So I still use the old rule, which is generally 2 times cause. Evaluating 0 depends on what the workload is of a large multiple.
Yeah, 0 is my favorite because there's a lot of locking overhead. Until InnoDB, Sun actually worked on some stuff with plugin. It was Sun that did the work that it reduces the locking overhead for setting the thread concurrency values. But there is overhead in setting that in any version other than that. Okay, so that's the end of the example. Please don't do Google-driven blindness of setting delayed key writes equals true, because it has negative consequences. Your crash recovery ends up being terribly long. So what's the best way to do this approach? The best way to do it is sometimes a trained eye helps, but you still miss things. Most of this can actually be automated. My favorite of these automation tools, and there's lots of them, is this one, Matthew Montgomery's Tuning Primer. I like this one because I know Matthew put a lot of work into saying, you may want to change this, or you may want to do that, and he doesn't describe things as definitive. And I think he's fairly honest in saying the edge cases in the information recommendations this tool spits out. And I don't think all the other tools do it that way. They work off the Google-driven blindness logic. Okay, 10 more seconds for people to write that down.
going to be online anyway.
Yeah, it's going to be online. But people might be excited. They might want to check it tonight, and Eric might only upload the slides tomorrow. So, okay, next point. Every setting has a range. You really can't have too much of a good thing. It takes more resources to allocate larger chunks of memory. You have a higher chance of missing something like a CPU cache, which tend to be very fast unless you miss them. So Peter Zaitsev, my boss, he blogged on sort buffer size, and the conventional wisdom was that if you have to sort a lot of data, you set this to bigger. He set it to smaller, and results were faster. Do the results make sense? No, not entirely. But it's interesting to see that you just cannot make assumptions. And in benchmarking in empirical proof, it turned out that bigger isn't better. Okay.
You know the reason for that?
I'm assuming CPU caches, because CPU caches are much faster than any other memory. And so in Linux as well, depending on how much memory you're allocating, it has one of two different algorithms. If you allocate a larger amount, I think it uses an mmap or something like that, and if you allocate a smaller amount, it's got some other algorithm.
No.
It switches, sorry?
It's a malloc. Then
Malloc.
Then it switches to mmap, yeah.
Okay.
Do you have the other examples with the read and rebrand on your blog? No.
Read and read. We're not speaking the same language at the moment.
Sorry. Also on the performance blog, you should do search for other things about the read buffer size and read R&D buffer size. There are more detailed examples which include specifically talking about increasing the size and hitting this change between malloc or tmalloc and mmap.
Yeah.
So there are other good examples if you don't have them in the slides.
Yeah, that's true. I've seen those examples I know what he's speaking about. I think they might actually link from here even.
Possibly.
I think this might have been a... Anyway.
From my past experience, I've seen in Oracle, sometimes when you reduce the block size, because Oracle supports different block sizes.
Yeah.
It depends on your application, how you utilize it. If your transaction is short, you benefit from the smaller block size. So in this case, what you're saying, what we have to do, we have to upgrade to build with first like 4K block size and basically actually 8K block size. So we have to downgrade to 4. That will boost up the performance. So what I'm saying here is, I'm not sure if that's across the board, increase the performance, but it depends on your application. You observe the performance.
This is probably a little bit different to block sizes as well, but
because that depends how the memory is being allocated, right?
Yeah.
And
I'm sure it differ by operating system. So these tests were Linux, and generally, when I speak on behalf of my customers, a lot of them are Linux. I'm sure if you tried this same test on Solaris or Windows, you'd get different results. So, okay. So when does this approach of just tuning settings work very well? I think it works really well with InnoDB. And the reason is that defaults in InnoDB are terrible. They're getting better in 5.4 and in ExtraDB, which is the reason for my little starburst I put up there today. And the reason that they're terrible is that the default recommendation of the InnoDB buffer pool size is to use 70 to 80% of your system memory. There are possibly some slightly better ways to calculate this, but let's say that 70 to 80% is the rule. My system has more than 10 megabytes of memory, and hopefully yours does too. And the other problem here is that the log files are 5 meg, and the practical range tends to be closer to like 64 to 256 meg for these. So I think in 5.4, I can't remember the new default for an InnoDB bufferable size. I think it might be 100 megabytes, which is still better, it's much larger.
I think it's at least a gig actually.
Even for the default, it's that big?
The defaults are significantly larger.
Yeah, I know that the default for the log file size is 64 megabytes. And this can make InnoDB, I think, if I had to quote a number, 50 times faster. These ones are important. And so here's a couple of tips about what to tune in MySQL and InnoDB after installation. These are the ones that matter.
I noticed one time when I installed Percona and I set up the MySQL installation with it, I noticed that it didn't use 2, but it used 3 log files. Why it increased?
That's a 5.4 thing. It changes from 2 to 3.
Oh, they did go to 3? Okay. So the answer is that there's another setting called InnoDB log files in group, and the default is 2, and you can set it to any number that you want.
Is 3 better?
No, I mean it's no different unless your operating system has a better thing. when you calculate the size of your log file, it's this multiplied by log files in group. So technically, if this is 5 meg and you've got 2, then it's kind of like a 10 meg log file. Some operating systems or file systems might not like bigger files, and that's why it's good to separate it up into more physical. But when InnoDB treats this like one logical file, it does not really care itself, unless the underlying system does, whether or not it's made of 2 files or 3 files. It's all the same from InnoDB's perspective. Yeah. Okay. So, what are the pros? How does this approach work? You can get some really quick wins sometimes, if you had misconfiguration. The cons, people make mistakes on this one sometimes. If you want to make a mistake, try it. Set your sort buffer size to 400 megabytes. Find out how. I think this approach is pretty good. It's pretty good to retrofit. I like it slightly more than the previous one, and I've changed my opinion on the previous one that I don't think it's really that easy to swap out hardware. This is really easy because I probably just have to restart MySQL and everything takes effect. So this is probably the quickest thing to activate, and the previous one's the second quickest. On to option 3. So this option should be called something like add an index, slightly rewrite a query, make some small tweaks here. This option is the least fun approach. It actually requires some real work. But we get some really awesome wins. So let me start by showing you this command. And if you haven't seen it before, this is explain. This shows you the execution plan inside MySQL. What MySQL is going to be doing to execute this query. So I'm going to disadvantage you by not telling you where the manual page is, and most people don't have laptops out, and ask you, what do you think that this is doing?
Full table scan.
Full table scan. How do we tell it's a full table scan?
Because it's type all and there's no keys.
Yeah, type all means full table scan. Possible keys that we've got here, nothing. So as a result, key that we've used, nothing. We examine 239 rows, and then after that, we have to do some sort of sort. This just means that we apply a filtering after we examine those rows. So that's what MySQL is telling us that it's doing for this query. Query, select name from country where constant equals Asia, population greater than 5 million, order by name. So let me throw out a question. How can we improve this query? Add an index on continent? Continent population? Comma population, okay. On name? Okay. There's a lot of index choices. That's absolutely true. Let's go through the rest of them. We could do continent. We could do continent population. We could do name. What else could we do?
We can do all 3, continent, population, and name.
We could do continent, population, and name. Could we do population?
Sure.
Sure, we could do population. We could do population, continent, name. We could do lots of things. All right. Which one's the best one? This is even more interesting.
Okay. Can you ask you a question?
Sure.
So let's say I have multiple ones. What I
Yeah.
found is MySQL really weird to which index it actually chooses at different circumstances. So you can do an explain, and it'll show you it's going to use one, and then as the table grows, it'll just start using the wrong one. Just crazy.
That happens. Yeah, yeah. So the answer to this is that the database has to pick the best path. What we're going to do now is we're going to add all of these indexes, and then we're going to see which one the database is picking, and if it's got it right. This is called the optimizer. I think in the beforehand thing we were talking about optimizing queries and how the optimizer works. So let me start by adding an index on population, and then repeating this this step here. So I'll just say country, add index P for population. Select name from country where continent equals Asia and population greater than 5 million, order by name. So type equals all. What did that mean? Table scan. Possible keys. P. So it knows our index exists. Key. Who wants to guess why we didn't use the index?
Because it's
second. Because it's the second.
Because it's the second thing. So we mentioned continent here, and then we mentioned population. Is that why?
I don't think so. I think it just made some stupid assumption on the condition of your comparison.
Yes, the
greater
condition
than
is
500 million or something. You just decided not to use the index.
It's probably the key population. I mean, the number of keys that where population is greater than 5 million is probably the lopsided index.
It starts to do a full table
Yeah.
but
Yeah. How do we explain this best? Ronald, do you want to fill this in? Cardinality.
Cardinality is the word I think everyone's trying to find.
Yeah.
Say it again.
So, cardinality. So I'll fill it in. What the database is doing here is really smart. This is the right decision. Population is mentioned second in this query. Doesn't matter. Optimizers are smart. They can work this out, that we mentioned it second. It knows the index is there. If we look at the query here, we're saying population greater than 5 million. And I read it out a few times just to trip everyone. There are very few countries in the world with a population less than 5 million. So in this case, if we were to apply this index, after we've done our very small amount of filtering, we still have a lot of work to do. And this example is similar to like how we, this index is a B tree. B trees are similar to how we look up a phone book, where we divide in the middle, and then we keep dividing until we find the record that we're after. Here we're after just about every record. So is it quicker for us to do this, or to just go cover to cover, skip over the 2 or 3 that don't apply? And MySQL knows that it's quicker to go cover to cover and skip over that 2 or 3, because it chose the full table scan even though the index was available.
How exactly does it know this?
It does it based off statistics in the index.
Which suck.
Sorry?
Very bad.
Well, they're good enough. They don't have to be 100%. Like sometimes when it tells you these numbers, they're estimates, but everything's an estimate. It'd be too expensive if we were 100% up to date.
What's MySQL rule of thumb in terms of the figuring out this?
Okay.
90%?
You have to, if I had to quote your general rule, I'd say that indexes have to filter out 80% of records to be effective if we're talking B trees, which is pretty much every index in MySQL. It's a very generic rule because that flipping point can be anywhere between 15 and 60%, and depends entirely on the table. But if you've got to think rule of thumb, sure.
Sorry, I was just waiting for your sentence. Just because you were asking about Oracle questions, the thing to add about this is in MySQL you can't choose whether what sampling is done or what percentage of data is actually sampled. So realize that you're relying on MySQL to make the best choice, and that differs depending on storage engines as well.
Yeah, storage engines report their statistics to MySQL. So some of these examples, if you try them between InnoDB and MyISM, they're going to be different as well. That's just how, well, they actually store the data different, so sometimes it makes sense for them to be different as well. Okay, so that makes sense. We full table scan. What would happen if we changed this query and we said population greater than 50 million? And I'm going to do that. And here, possible keys P, key that we've used, P. Fantastic, it works. There's a lot fewer countries in the world with a population greater than 50 million. Rows that we expect to examine on disk after that, 54. From that 54, we do some second stage filtering when looking at those table rows, and then we sort them. We sort them because we've got this order by name. Okay, let's add another index, and let's compare it. So let's add an index on consonant and repeat the query. Here we have, I think, 50 million still. And it says possible keys P and C, key that we've used C. I'm going to flip between these two, and then I'm going to ask you the question, why did it choose C? So look at this slide, and then let's skip back and look at this one.
Because it's a constant reference.
And then skip back again. Yeah, you're right. Like if we look at this input, it's a constant. If we look at this one, it's a range. This is slightly cheaper for us to do. So if we get the choice, we'll pick this one. There's actually 2 more reasons why we picked this one. Did anyone spot the other ones?
There's a small country that measures this criteria in Asia.
Yeah, if we look at the rows that we had to look at, this one's 42, and this one is 54. So our estimate is that we're examining fewer rows once we have to look at those table rows. So that makes this one cheaper. There's one more reason. What's the other reason?
Length of the key.
The length of the key here is 1 byte. It's an enum internally for storage. The length of the one here is 4 bytes. So MySQL adds all of these together into a formula called cost. And then it says which one is the cheapest. And in this case, it's conclusive. Continent's better. What if I change my query slightly and I said population greater than 500 million? What happens there? So who thinks that we use the population index if we said population greater than 500 million? This is like, are you smarter than a database? Okay. Yeah, maybe. Who thinks we still use the continent? Okay. We use the population index if we switch it to 500 million. Yeah, only 4 rows. It actually turns out there's only 2 rows. This shows you where that's that experiment. I think it's only India and China are greater than 500 million. But this ends up being cheaper in MySQL's thoughts. It can be wrong. I haven't benchmarked this, but it's hopefully close enough. All right, next one. Let's get into the composite indexes, where we add indexes on more than one column. Population continent, and then repeat this query. So population continent, I've called the index PC. Type ref, we've got PC and PC. We ended up just using C. That's weird. Why is that?
Wrong order.
Wrong order? It is the wrong order, but we'll get to that. Any other thoughts?
Less reads. The optimizer has to do less reads because
length of a key would be longer too.
Key size.
Yeah, so I have a few theories on this one. Sometimes it works out better that if you get the same information from the smaller index, you're better off using the smaller index. There's some cases that might make sense, and this one it doesn't, actually. This one is just a missing optimization in MySQL. I wish it weren't true, but with MySQL, it's very rare that after you do a range type, like on population, that it can do a constant after that range. So not unless you use like an in-list or something like that, that it can do any constant comparison after it does the range.
Can I tell you what I do and tell me if it's stupid?
Sure, go for it.
If I have more than 2 indexes, I always force the one I want because I just don't trust this.
Yeah, this is called an optimizer hint. So I use optimizer hints sparingly. I would only use a hint if the database is wrong by a long shot. The reason is that as your data distribution changes, you've just locked yourself into a decision. Whereas if you just let it free flow, then the database can switch as plans get cheaper. So I would not recommend that in case the database is significantly wrong.
Can you sample it periodically? I mean, after all, databases don't change in a second, right? They change over time.
So you cannot control MySQL sampling, no. You can ask it to resample, but you can't control InnoDB's automatic sampling. There are patches that are out there to do that. They're not incorporated, into any builds. There's one patch in 5.0 and 5.1 to not update stats on metadata commands, like show table status and stuff like that, but that's the closest.
No, sorry. Like changing hints over time. Like knowing that, oh, my data changed, I use different hints.
You could revisit your hints, but that's just more legwork for you to be able to do that. I would generally, as a course of action, not use hints unless the database is significantly wrong, because it's just too much work to maintain. Like if I'm working on a system and it's just got hints everywhere, often that's just a symptom to me of bad design. I often find that someone's made some assumption and they've been wrong, and I have to start making changes. That's just my experience.
What if you do a loop with monitoring,
What if you just don't use hints? Yeah.
Well, what I'd like to add there is possibly that in most of the cases where MySQL is picking the wrong index, it means you have too many, which can be almost as bad as not having enough because of the overhead of maintaining those indexes, especially in a write-heavy situation. And maybe that you need to restructure your query to let the optimizer pick the proper index rather than trying to shoehorn it into the index that you know.
This is possible, and this is an interesting point, specifically for an optimization introduced in MySQL 5.0. Because let's say that we've got a table with a join on 3 tables. Each table has 6 indexes. Then I think we have, do we have 6 times 3 times, I don't know how the math works out, but we've got a lot of different situations that we could choose from. In MySQL 4.1, let's say for argument's sake, we could have spent 5 seconds trying to figure out which is the best plan, and like half a second to execute it, because there's just too many choices. In MySQL 5.0, it starts discounting plans very quickly and tries to just negate the bad ones, and doesn't exhaustively search. That's called the greedy optimizer. And this is just part of processing, that we don't have to be 100% accurate, we try and get good enough within the parameters that we can. So that was one of my favorite improvements in MySQL 5.0 in terms of optimizer. There's a few in MySQL 5.0 that were reasonably nice. Index merge was another one. It has some strong points and some weak points. If you have an OR query where you're ORing on 2 different columns, you can do an index merge on that, which it could.
You're using.
Sure.
Would the index become irrelevant since you have a composite PC? Because it can use the same index to...
Yes, it would. Yes, it would, absolutely. The P index would become irrelevant when I have PC. You would not add all these indexes on production. I'm just being a fool to show you how it works.
You know, I was thinking in terms of cardinality of keys, what I've often found handy is to take the table and say, for example, on the index that's P, I would say do select count 1, comma, population from country, group by population. Then you can see how lopsided the keys are. And likewise, you do that with continent, you do that with population continent, and that way you can visually see why certain keys produce table scans while other keys will actually use the index or range scan.
You really have to do this on a query-by-query basis. I blog posted about a week or 2 ago saying how not to find bad indexes. There's this thing on a website that I won't mention where it shows you that you can find indexes that have really bad cardinality, which means they have very few unique rows, and then try and delete those because they're bad indexes. I think that's not true. It really depends on queries. I could have a table that has, let's say it's a sales table was my example in my blog post, which has one field, active, and it's like yes or no. And if no is 99% and yes is 1%, if my queries all say where active equals yes, that's a fantastic index, but the cardinality is very low. And the flip side of that, that automated tool is that the cardinality of population is actually very high. But if all my queries set population greater than 5 million, that's a bad index. I think you really need to throw individual queries at your database and see whether or not it's using indexes to know if indexes are effective.
I should just add that when you're looking at one query to optimize, that's not the totality of the system. You know, making a change in one table or adding or changing an index could actually make something else worse. You always have to look at the totality of your SQL statements. And I've yet to find a single client who has actually kept a copy of every SQL statement that they execute against the database. It should be a goal in application development and in your development process to review every SQL statement and then work out what's actually better for our indexes.
Yeah, I'll add to that as well. Like, there's this feature called MySQL Slow Log, and you can say like what queries to log. And it used to only be able to log queries that take 1 second or more in 5.0. In 5.1, or if you use a patch 5.0, you can set that to 0. And I often set it to 0, and I log every query, and then I aggregate that information in total. Because I care about every query, not just some arbitrary number.
Why would you do that when you have the binary log?
The binary log only logs statements that update.
Right.
And generally, I'm updating based on a primary or secondary key. My selects are the ones that are just all over the place.
Are there any tools that, you know, can analyze the...
Sure, yeah. I don't talk about it here, but I've got an extra 5 slides at the end of my talk for when you download them, which shows you how to aggregate your slow query log. And it's called MK Query Digest. It's part of MartKit, and it's awesome. All right, so I think I might speed up because I think I'm a little bit behind where I wanted to be. So this is a missing optimization in MySQL. It's bad, you have to live with it, sorry. The successful answer here is that if you want to add a composite index, remember, ranges to the right, ranges
population from greater than to an equal, would that stop doing using the file sort?
No.
But you're just doing a lookup on the name with the last column of the index, which should be sorted, right?
Unless we did order by population, comma name, then it wouldn't avoid that file sort. Because things are ordered in the index by population.
Right, but if you change the population from a greater than to an equal sign, you're just doing a lookup instead of a range scan.
If population was constant, then I believe
Yes.
we'll still be able to use the order by using the final.
You would still have to do a sort though, because if you're ordering based on the population, which would then mean that we'd have to sort still when we want the name in order. If we said order by population common name, then we could avoid the file sort. As long as we were just after Asia. But it's the only way. We need to do population common name in the order by to avoid.
Well, in that case, we need a continent population name in the order by.
Yeah, that's what I said.
Okay.
Yeah.
Which you can do.
You can do it, yeah.
If both continent population are constant.
You could do that off the range still as well. You could have, if you did order by population common name, this would probably not file sort.
Right, but if you get rid of the range and use an equal,
it's still sort. Yeah. You have to. Okay. So I'll try and speed up. What's the end result here? We're looking at 9 rows, not the whole table. Small example, fantastic results. We're just looking from the index as well, and we're bypassing this table. The wins from this can be massive. If I said to the first one, maybe with hardware improvements, we might get 5 times. The next one, we might be 50 times. This is kind of unbounded in improvements. I've seen 1,000 times better. Use indexes, it's the best way. Another example, and I'll try and do this one really quick. Did you have a question? Or, no? All right. Is this same command can be used for join analysis. Here we have a query where I'm doing a subquery, and it says that it's looking on the first table, it's table scanning, and then it thinks that this next thing is a dependent subquery. So for this inner loop, it thinks that I need to kind of repeat this each time for the outer thing. So I know a little bit about MySQL. I know that it can't optimize this subquery very well, where it could have just eliminated this as a constant and then proceeded. So for it to eliminate it as a constant and then just proceed, or what I have to do first is I have to rewrite this to a join. And so I rewrote it to a join like this. This is the common join syntax. Lots of people hate it. They prefer the inner join. Does this show up any different and explain? No, it should be the same. That's just a little bit of trivia. The database, it's got an optimizer. It's supposed to figure out that this is the same. We're still looking at the city table. Then we're looking at the country table. So I thought to myself, okay, now that I've rewritten this as a join, what's the next step? I'm going to add an index. Where do I add the index? Well, I thought I might add the index on city, on the column called country code, and then I repeated this. And here I've got the possible index, but I'm still doing a full table scan, still looking at about 4,000 rows, and I'm still doing my work here. And I was thinking, what did I do wrong? Well, I did something right, which is I tried to re-verify what the database was doing afterwards. You always need to revisit explain anytime you add an index. But the thing that I did wrong was I didn't look at where I should be looking to add my indexes. And if you want to know the place to start, look at what's in the where clause. Because we have to filter information first, and then we can proceed. Now, if I think clearly that way, there's really only one choice here. If I add an index on country.name, this is going to be awesome. And so I do that, country.name. And here I see that I look at the country table first. This is reliable in the order that the database is going to be looking. Before it said city first, now it says country. I find one row in the country table, and then I can proceed and join on the city table, where I look at 18 rows. This one is awesomely better than that original subquery. So I'm almost done on this section, and I'm just going to recap. Focus on the components of the where clause, and just be aware that the optimizer does cool things. This is what a database is supposed to do. So if I ask the question, this is query 1 and this is query 2, who thinks query 1 is faster? How about query 2? Yeah, maybe? And who thinks that they're the same? ID is a primary key. That's the thing that I left out. Yeah, if they're a primary key, then they're the same. I agree with you. And then the third and the fourth one, select star from city where ID between 100 and 200, or select star from city where ID greater than or equal to 100 and ID less than or equal to 200. I hope they're the same as well. So the real answer to this question is, what does explain say? That's the answer. In this case, explain says they're the same, so I'm willing to more or less say that they're the same as well. There's some things that explain can't tell us yet. So if this were not a primary key, we couldn't tell yet. It can't tell us about that limit optimization if it's not a primary key. Question?
I would add that in this example, the second example is a poor case. Because sometimes when you're a developer, you don't look at the explain, you just look at the SQL. So if you look at the second SQL, you can't make an assumption that ID is in fact a primary key or a non-unique key. Where in the first, well, sorry.
I would never put limit 1
on a primary key.
Yeah. This to me, I mean, if we wanted to split hairs, this probably takes longer because it's got more passing overhead, but I'm not going to split hairs. I think that this just describes a fundamental lack of understanding of how your database works. I've heard people say to me that, well, what if my database changes and ID is no longer a primary key? And I think that's just not valid. You should really understand your database. You should know this is a primary key. Because it's a primary key, you don't add anything like limit 1. That's my theory. Answer number 2. What's the difference between these two? Nothing. They're the same. And I can answer that if you said we're ID in 100, 101, 102, 103, up to 200, it would be the same as well. But I would not recommend doing that. Okay. So if you want to learn more about this approach, I recommend 2 books. And I've got the books, and I'm happy to give them out. So the first one, I'm biased, I co-authored. And the second one, I'm biased, my boss co-authored. So they're both very good. But to recap on this approach, this is my number 1 recommendation of how you should start tuning a system. It's really good. It takes a little bit of work for analysis. Sometimes you have to rewrite queries slightly, like that subquery to a join, in which case you have to go inside the application. Not everybody can. If I had to review these options and give it a scoreboard, here's how I'd compare them. Adding index takes a little bit more effort, but it takes a bit more time. I used to say that adding hardware is not much effort, but it is because you've got to switch out things. So maybe this is like a 2 or a 3. It's not that easy. And tweaking settings, it's generally fairly easy, but your wins is sort of limited. Okay, good. Last section of the day, third-party patches. So I guess when we start this, I sort of want to show my respect to Sun. I think that they were really brave by releasing 5.4, which isn't out yet, as a performance-only release. A lot of the previous releases, if we look at 5.0 and 5.1, they were just aiming at features. And when I speak on behalf of my customers, they care about performance. So my slide deck would have been much thicker maybe about 6 months ago. So I'm not going to talk about performance for third-party patches. I'm going to talk about diagnostics and issue Sun a challenge to keep 5.4 going and make it better. So patch number 1 that I'm going to talk about is slow query log filtering. Here I have 2 sample queries on a table. They're almost identical. On the first one, I'm selecting employees where the birth date is between 2 dates, order by random. And the second one, I'm doing the same thing, no order by. So the first one, what does it look like if we look at explain? Well, it looks like this. We have to look at about 11,000 rows. After we look at them, we have to put them in a temporary table and we have to sort them to be able to satisfy this order by rand. The second one, well, it's much the same, except we don't have to create that temporary table and we don't have to do that sort. So I showed you on this slide, this one took 0.63 seconds, this one took 0.25 seconds. So now that we've looked at that, we know that the second query is going to be faster if it doesn't have to do that sorting. But if we talk about speed, that's not really the only measurement. The other measurement that we have to look at is scalability. It's not the same question. So any test in real life has to represent some sort of concurrency. So I wrote a test, and I tested these two queries in a concurrency of 1, 2, 4, 8, 16, etc. And then I showed this on a graph. And we can see that the one that had to create the temporary table, it starts hockey sticking up much quicker. Why does it do that? I can only assume. My assumption is that because I had to do a sort and because I had to create a temporary table, it hit another bottleneck faster. In this case, my disk. And so, you know, sometimes it's more important to not just think about what's going to be slower, what's going to be more expensive, and what's not going to allow me to exploit the concurrency that my server can offer. So some examples of these things, sure?
Wasn't one like almost a half a second faster? Like a third of a second faster?
They were about, one was about double the speed, and then in the graph...
0.25 versus 0.6, right?
Yeah.
That's pretty big difference, actually.
This one stays flat for a lot longer, and this one shoots up faster.
But even the initial query was 0.3 seconds or so faster.
Yeah.
4 seconds faster.
Yeah.
That's a lot.
It is a lot, but it gets worse, is my point.
Of course, yeah.
Yeah.
But still a lot.
So it's high, but yeah, my point is just concurrency.
Okay.
Concurrency is important. It has to be part of any test. So, and as part of that, I want to know what is potentially expensive, or is it going to allow me to scale, not just what's slow. And these are these things that could all count as that. Particularly things that touch disks is what I care about, like temporary tables on disk, or file sorts on disk. I care about those two. And in a patch, now what I can do is say log slow filter. So I can filter and identify these things, and then try and mine them out. As part of this same patch, I can set log slow verbosity. And so I can find extra execution information when I write it to the slow query log. Like, did it create a disk temporary table? Did it create a file sort on disk? And this is awesome. I can really do stuff with this information. So this is a patch in Percona's 5.0 release. It hasn't been forwarded to any other releases, so it's not in Percona 5.1. It's not in InnoDB 5.1, 5.4, anything like that. But I hope it will be.
It's not InnoDB specific, is it?
No. No, it can work with my ISM tables. The stats here are oriented towards InnoDB with some of these. All right. What else can this thing do? Well, if you use this one in 5.0, it can let you set a small or long query time, which is awesome. 1 second is just infinite in terms of page generation. If all my pages took 1 second to generate, that would be awful. And considering I do more than one query to generate a page, that's even more awful. So this patch, if you want more information, it's documented here. This was authored by the company I work for, Percona. And my second patch, and this is my last patch for tonight, is this one, index statistics. So what were the possible indexes here? This was an interesting one. I show this example everywhere, and a lot of people suggest the wrong ones. Here are the right ones: constant population name. Here are the wrong ones. And then the question from that is that what would you do, or how would you know if you added the wrong index, given that indexes hurt write performance? So we're disadvantaging ourselves by having that added. And in MySQL, you cannot do that. There's no way to find dead indexes other than dropping all the indexes and starting again. And these things change over time, so indexes is just a routine maintenance thing that you should be doing. And so there's a patch that this one was originally authored by Google called Index Statistics. And this is in the Percona 5.0 releases. And what you can do with this one is each time an index is read, it just increments a counter. And from that counter, I can do queries to be able to find indexes that are unused. And here's an example of using this that's on our blog. Very simple tool. You can find indexes that need to be dropped or tweaked. Very little overhead. Retrofits very nicely. Actually comes as part of a bigger patch with index statistics, user statistics, table statistics, and that's the documentation there. So with that, I'd like to finish. I'd like to finish with a few announcements. I try to reproduce stuff that comes from our blog, so if you're not reading it, I recommend it. It's awesome. We're a consulting company. Our most popular service is a performance audit. It's not 100% like what I did today, but we've got a blog post on how we do it. If you've got performance problems, you're welcome to hire me. I'm in town to deliver training on Friday. If you didn't know about it, we have 4 seats left, and here's the link to that here. And I have 2 books to give away, and some stickers somewhere as well, for Percona stickers. So, Eric, do you want to decide how to give the books away?
Okay, we'll do the book thing in about a second. I just want to give a special thanks to our sponsors. Of course, Sun Microsystems, our sponsor, is very appropriate since the MySQL group. VORK, the Enterprise High Performance Web Framework. That's our sponsor. If you haven't noticed it in the emails, it's vork.us, www.vork.us. Try it out. It supports every database, MySQL, Amazon's new RDS, MongoDB, every database under the sun. So try it out. And as for contests, we did that. What did we do? A hat last time. Who was here last time? We had a hat thing when I wrote through their name in. Well, okay, it doesn't really matter, I suppose.
We can ask technical questions as well.
Yeah, that's.
And the person who doesn't answer them gets the book.
Yeah, do a technical question. Okay, that's good.
All right. In MySQL 5.0, there are 2 row formats for InnoDB. What are the names of both of them? In MySQL 5.0 with InnoDB,